Hey, welcome back everybody. In this final video, in this sort of abbreviated radical piece, we're going to talk about adding and subtracting radical expressions, specifically square roots. And I've made a couple of examples, and I hope these are going to be enough for us and helpful. If they're not, let me know, and we'll see what we can do. All right, so in terms of a rule here, I kind of just came up with this, okay? This we'll call 8.1.5, adding and subtracting radicals. And then again, this is specifically square roots we're going to work with today. But more generally, not specifically, this is what has to happen before we can do this, okay? So this is a big rule. All right, for us to add and subtract these things, they have to have like indices and like radicands. Now, I use the word indices here. That's just plural for an index, okay? The index of a radical is right here. The reason you don't see anything there because these are square roots. And when square roots are so common, I suppose they don't put a number there. Kind of like if we're raising something to the 1 power, we don't write a 1 there, you know. So anything larger than a 2, they start putting them in. Like cube root, well, there'd be a 3 there. Fourth root, there'd be a 4 there. So in other words, these have to be the same before you can add them. All right. Another thing that has to be true, the radicand, the number inside, has to be the same. If it's not, you cannot combine it. All right. And it's just that simple. You can't combine everything. So something can be simplified and not combined. It's okay. They just won't combine. Like if someone told you to add x plus y, that is as simple as it can be written. You can't combine the two things, okay? All right, so this says simplify the expression. And this is really, really simple. Let's see, does it meet the criteria? We have the same indices, yes, they are the same. Now, what's like here, the radicands, yes, we have the root 3 and a root 3. So this can be summed up. Now, the way this technically works, let me show you the technical way. And I'm just going to, it'll just appear kind of magically right here. All right, by the distributive property, a root 3 can be factored out of this. And then you can just sum up the numbers in front and you get 7 root 3. All right, so we're going to assume that from now on. That's going to be our, okay, yeah, whatever. I'm never going to probably write this again because it's a lot of needless work. So what I want you to do is when you see that the indices are the same and they have like radicands, you can add the numbers out front. Kind of like you add when you sum up algebraic expressions, combining like terms, you just add the numbers in front and you can do that. 2 plus 5 is 7 and is 7 root 3. All right? Okay. So let's get to an example that might be a little bit more complicated than that. And I've got one down here in example 2, and it's a subtraction. Oh, by the way, I didn't mention that. Subtraction works the same way. If this had been a minus 2 root 3 minus root 5 would be negative 3 root 3. All right, so you just subtract the numbers in the front. All right, so we're asked to simplify this expression. And looking at this, we might just say, well, we can't. They're not like. He fails the like radicand test. We have like indices, but we do not have a like radicand. Well, if we said that, we'd be wrong because we needed to simplify this root 8 first. All right, so this root 8 needs to be simplified, and probably want to work with that on the paintbrush here. And let's write that down. So we have 3 square root of 8, and I'm supposed to subtract the square root of 2. All right, now if we're going to simplify this square root of 8, we realize that this is 3 times the square root of 4 times the square root of 2. Because the square root of 8 is 4 times 2. And we're still minus root 2. Now 3 times the square root of 4, square root of 4 is 2, so 3 times 2 is 6. We have 6 root 2 minus 1 root 2. I'll call that 1 root 2 just to illustrate my point here. All right. Now, all we're going to do is take the numbers in front, because now we have like radicands. We didn't see that right out of the gate, but we simplified it so we can see it, and we'll get 5 root 2. And again, like I told you in the last video, one way to kind of convince yourself this is all working out is throw it in the calculator and get you an approximation. So especially if you were going to submit this in a IXL or something like that, you don't want to get your points dropped. Minus square root of 2. Let's get an approximation for this first. Okay, so we come up with 7.07 or something like that. Now let's calculate our outcome. And we get the same thing. And now we know this is simplified because there is no perfect square factor inside this radicand. All right, so I hope you found this video helpful. I think that'll probably wrap this up for us in this beginning of this module. And you guys, I'll see you on the next video. Be safe and stay healthy.